Hello, my name is METİN. This is 214th part of explanation of my theory. According to my theory and my formulas, variable Planck's constant on black hole's surface, angular momentum is not conserved on black hole's surface. For instance, angular momentum is not conserved on spiral galaxies. 1. Last year I had found and I have told you that the Planck's constant is nothing but the angular momentum on an inseparable point of the surface of electron motion form and its successive waves. Here, snapshot. These results for at rest, not relocating, 91.155 nanometer wavelength size kind electron motion form, that most common in our universes in atoms. These results are the same for all different wavelength size kind electron motion forms. In accepted physics theories, photon is massless particle and an electron is dimensionless point particle. If I had accepted these two ideas, I wouldn't have been able to come up with these results, because I wouldn't find mass of photon, then I wouldn't find wavelength of electron motion form. My electron motion form picture is different. I have told you before. I advise you, if you want, I advise you to watch my former videos, step by step. Planck's constant, angular momentum, speed of light, direction, mass of an electron motion form, point mass, wavelength, initial wavelength of electron motion form, and speed of light. This is Planck's constant, 6.626 10 to the minus 34 kilogram meter squared divided by second. Again, here, angular momentum, Planck's constant, linear velocity, 1,884,000 kilometers per second for first wave, linear velocity, okay, component of electron motion form. This is linear velocity component mass, lambda normal, and linear velocity 2 pi c is equal to 1,884,000 kilometers per second. Same result. Okay. Yes. According to me, the photon is inseparable point of the surface of the electron motion form. It is not a particle and it has mass. Last year I have computed and I have told you This is 2.423 10 to the minus 35 kilogram. Speed of light, direction, mass, point mass. Here 3.85 82 10 to the minus 36 kilogram. Linear velocity component mass. Yes. Yes. 2. When an electron motion form relocates linearly or rotational, but here linear. When an electron motion form relocates, in fact, when an electron motion form relocates, its point wavelength, point wave velocity, point energy, point angular momentum, say variable Planck's constant, point mass, point linear velocity change, vary, depend on electron motion forms, relocating velocity, direction, and orientation. 3. As I told you before, black hole is a giant electron motion form. Open-ended. Open-ended. Here. Okay. Yes. Black hole is a giant electron motion form. Therefore, all of the laws of electron motion form are valid for all black holes also. Yes. Snapshot. Thus, when a giant electron motion form, I'm so sorry, like this. This is in the middle of black holes. Giant electron motion forms motion arrow axis and it rotates around its axis here. Yes. Here electron motion form linearly relocates. Here giant electron motion form rotates around its axis, but the laws is the same. Okay. Variability is the same in principle. Here you see point mass change. Linear velocity, point linear velocity change. Here again change. Okay. Snapshot. Yes. Thus, when a giant electron motion form rotates around its motion arrow axis, at each point of its surface, angular momentum, say variable Planck's constant, will change at each point of giant electron motion form. In other words, at each point of black hole, point wave velocity, point wavelength, etc. will change. These mean at each inseparable point of a black hole. In other words, at each photon on the surface of it, angular momentum, mass, linear velocity, energy, wave velocity, wavelength will change. All of these will be variable. 4. All of these mean angular momentum will not be conserved at each point. 5. As I have told you before, for instance, spiral galactic formation actualizes around a black hole, which rotates around its own axis. Galactic formation actualizes by imitating black hole spherical motion lines bidirectionally. This means, for instance, angular momentum is not conserved for a spiral galaxy also. Here, snapshot. This is for linearly relocating electron motion form, how angular momentum changes here. How Planck's constant is variable here. Yes. Wait a moment, please. Yes. Wait a moment, please. Here, how Planck's constant changes. How does Planck's constant or angular momentum change? Here, for linearly relocating electron motion form. Here, rotational motion may be different results, but principle is the same. Here, angular momentum changes. Yes. Have a good evening. See you later.